This example says that given OPQ is a sector of radius 1 and the central angle pi over 3, which is 60 degrees. So we are given a sector which is OPQ. The radius is 1 means OQ, OC, OP is 1. Then we have a point C is a moving point on the arc of PQ. C moves along the arc PQ. And you can see how it moves. Like that. This is point C is moving along on the arc PQ. And then ABCD is the rectangle. ABCD is the rectangle embedded in the sector. So in the sector OPQ, there is a embedded rectangle ABCD. We denote COP this angle, COP this marked angle by alpha. So you see this is angle alpha, which is COP. We want to know at which point on the arc, C at which point on the arc will make this embedded rectangle be the maximum. Here it is written that what value will alpha choose to make the rectangle area be the maximum. Okay, and what is the maximum area? So we want to determine the location of C on the arc. At this spot, the embedded rectangle will be the maximum value. How to solve this problem? Before we do that, keep in our mind that we are working in the unit circle. That means OC is 1. And then we are given the central angle, POQ is 60 degrees. We are given that, never change. The only thing change is the C moving along PQ. So we want to determine this location C. Basically, we want to determine alpha. If we know alpha, then we know the location C, then we should be able to find out this rectangle. And then we should know this area. Okay. Now, let's see how we are going to find out this area. The formula for this rectangle area is AB times BC. Again, C has X coordinate, OB, Y coordinate, BC. So then we know is that the BC shall be sine alpha. AB shall be cosine alpha for this C point C. Okay, since the area S equals AB times BC, width times height, and we know BC is the Y coordinate of C. So then it will be AB times BC. Okay. Now we know AB is the difference of OB minus OA. OB, the longer one, minus OA, that will be the short one. So then the difference will be line segment AB. So the line segment is OB minus LA. Remember, OB is the x-coordinate of C, so that will be cosine alpha. So BC expressed by sine alpha and OB expressed by cosine alpha. This OB is cosine alpha. So we like to use alpha to denote OA, to denote this LA. Actually, OA equals AD or sine alpha times radical 3 over 3. Again, AD, BC are equal. Since BC is sine alpha y-coordinate of C, then AD will be sine alpha. So AD is actually sine alpha. Sine alpha times radical 3 over 3 will be OA, will be this part. Okay, and here is the explanation. Okay, again, AD or sine alpha times radical 3 over 3 is OA. And here is the explanation why OA can be equal to sine alpha times radical 3 over 3. Now look, AD over OA, in the triangle, right triangle OAD, you have opposite side over adjacent side OA is tangent pi over 3, which is tangent 60 degrees. Okay, through some algebra, you can have OA, this one, equals AD OA equals AD times radical 3. You rationalize this expression, you will have a radical 3 over 3. Both numerator and denominator multiplied by radical 3. So basically what we get here is OA again equals sine alpha, which is AD times radical 3 over 3. I have written that the reason AD over OA is tangent 60 degrees, and then eventually we'll have OA equals radical 3 over 3 times AD. You may pause it right here and study a little bit algebra here. Quite easy. Pause the video and see why. Okay, now let me move this away. So then basically the area will be S will be cosine alpha, which is OB, minus radical 3 over 3 sine alpha, which is OA. This part is OA, so minus OA, times sine alpha. Sine alpha is BC. Okay. Now from here, you do some algebra, you eventually will get 1 over radical 3 times sine 2 alpha plus pi over 6 minus radical 3 over 6. The details have been explained a little bit. It's sine alpha times cosine alpha, you have that. Sine alpha times sine alpha is sine alpha squared. From here to here, you got to use the double angle formula, because cosine 2 alpha is 1 minus 2 sine alpha squared. Okay? You see here is from 3 come to 6. It's because some algebra here involved. Review the previous one. Here sine alpha, cosine alpha, you multiply by 2 over 2. So the numerator 2 sine alpha cosine alpha gives you sine 2 alpha. Downstairs you have a 2, so you leave it alone. Then keep going from here to the one right here. Pull 1 over radical 3 out. Then inside you have that. You may distribute 1 over radical 3 to first term and second term. You should be able to go back. Details will be left to the reader. Okay. Now here, again, from here to here, is use the sum formula for sine. Okay, remember, sine one angle plus another will be sine, cosine, and then cosine, sine. You got to recall that formula. Now we get is this one. Remember, the maximum value for sine is 1. So when sine a quantity is 1, you will have a sine quantity is 1 times 1 over radical 3 is maximum for this. Subtract radical 3 over 6, you then have that. Okay, now this eventually equals that. Is you can rationalize this one 1 over radical 3. Okay, both numerator denominator multiplied by radical 3. So you have a radical 3 over 3 and multiplied by 2 on both numerator and the denominator. So eventually you have a maximum value for the area. Will be radical 3 over 6. Well, at which place you have a sine alpha is 1. We know you have a sine 2 alpha plus pi over 6 is 1. Well, if you have a sine pi over 2, then the value will be 1. So you may assume that 2 alpha plus pi over 6 equals pi over 2. You then solve for alpha. You will have a pi alpha equals pi over 6. So at alpha equals 30 degrees, you will have a maximum value radical 3 over 6. Okay, that's where. That's 1 alpha is 30 degrees of pi over 6. Then you have this point. We know the total area central. The central angle is pi over 3 is 60 degrees. So you cut this angle in half. that will be 30 degrees. So C is right in the middle between PQ. You then draw a rectangle. This rectangle will be the maximum. Okay, will be the maximum value. All right, I'll see you next time.